Okay, quick lesson on normal stress. This is the first thing you really get to as far as solids goes in the solids book. We've got our very first equation, and we're going to talk about, there it is right there, sigma equals P over A, and sigma is normal stress. Let's talk about what is normal stress. What is normal stress? Well, remember when we cut a beam, if we had a beam, remember from statics, what happens when you cut a beam? You must have M and V. Remember that? When we cut a beam, we must have an M, N, and a V. Well, N is the normal force, and what is that normal force doing? It's trying to make that beam longer or shorter, right? So a normal force is always the stress that's axial. It's the one that's trying to make a shaft or a beam longer or shorter. So I'm either pulling on it or pushing on it. So it's either tension or compression, okay? So we call this normal stress, okay? And again, stress is kind of like the measure of the intensity of a force across a body, okay? So we say P, but what we really ought to say is F divided by A. It's the force in that member divided by the member's cross-sectional area. And in the English system, the units for this are going to be what? On the top I would have pounds. On the bottom I might have square inches, which is going to be pounds per square inch. In the metric system, what would it be? Maybe newtons over meter squared. And do you remember what a newton over meter squared is? Okay, here we go. How about, and a newton is what? A kilogram meter per second squared is a newton, right? But if we do a newton divided by a meter squared, that's a Pascal, okay? And here's another very common unit is a newton over millimeter squared. Here's how I remember this. Hey, I've got an extra M, so it goes in the front. That's a megapascal, right? There's my extra M. So newtons over meter square, Pascal, newtons over millimeter square, megapascal. And that would be, so this is a Pascal, okay? Or a Pascal, depending on how you pronounce that. That's the units for normal stress, for stress here, okay? So let's work a little simple problem here, okay? I've got a red light, and it's hanging, it's 75 kilograms. It's hanging from 2 cables between a building. So let's say that the goal here, well, here it is right here. Find the normal stress in cable AB and AC. Let's put one more thing in there. Let's say the diameter of the cable is, let's say it's 20 millimeters. Okay? That's a cabe, not a cable. There you go. That's better. My English isn't so very good sometimes, y'all. Okay, so let's see if we can do this. The very first thing I've got to do is I've got to find this, the force in those cables. You know what this looks like to me? This looks like a statics problem, doesn't it, y'all? That's why I say statics and solids go hand in hand. I got to do the statics before I can do the solids, okay? So let me erase this. Let's do this. Let's find what this is. We're going to find the force in these cables. Now, force is in newtons, okay? This is in kilograms. How do I get that into newtons? Well, times 9.81, right? That's meters per second squared. That gives me a kilogram meter per second squared, which is a newton, right? So that's 75 times 9.81. 735.75. Okay? That's how much the light weighs, okay? So let's see if we can find out the tension in cable BC and BA. Remember, this is just a simple statics problem. This is forces about a point. Let's take a free body diagram of point B, and we get this. We get, this is BC, this is BA, and this is 735.75. Okay? I should always draw my drawing over there so I don't stand in front of it. Okay, here we go. let's, what do you think? Take the sum of the force in the x and the y. Okay, so sum of the forces in the x equals to 0 equals, okay, this is 50, this is 30. So in the x I have what? Minus BA cos 50 plus BC cos 30. Okay, and let's see, cos 50 is 0.643. So 0.643 BA is equal to, cosine of 30 is 0.866, isn't it? 0.866 BC. So BA is equal to 0.866 divided by 0.643 is equal to 1.34. 1.35 actually. BC, okay, so there's one, and then we do the sum of the forces in the y direction, and what do we get there? What do we get? We get, let's see, BA sine of 50 plus BC sine of 30 equals to 735.75. Do a little substitution for BA right there. And so we're going to put in for BA 1.35 BC times the sine of 50 plus BC sine of 30 equals 735.75. And so let's see, what the sine of 30 is what? 0.5, right? So here we go. 1.35 times the sine of 50 is 1.034. Oh, we're gonna add to that plus 0.5, right? So 1.53. 1.53 BC is equal to 735. That's how you make a 5. 0.75. I almost did it again. And so then I divide that into there. So 735.75 divided by answer. So BC equals 479.6. So let's just call it 480. And if BC is 480, then BA, right? BA must be equal to that times 1.35, 647.4. Oh, this is going to bug me if I don't put enough decimals on here. Let me do this. 79.6. Okay? So now we have, this is statics, right? I found the force in BA, I found the force in BC. So here we go. Let's find the normal stress, sigma BA, and then let's find sigma BC. Okay? Now both cables are the same. They're 20 millimeters in diameter. So BA, the force in BA is there, 647.4 newtons divided by, what's the area? What's the area? Now the cross section is a circle, right? With a diameter of 20 millimeters. That's just pi r squared, isn't it? You ever wonder why pi r squared? Pi are round and cake are square, isn't it? That's a bad joke. Okay, here we go. Pi r is 10 millimeters. I kind of entertain myself sometimes. Squared. Okay, and the bottom one is what? It's 479.6 newtons. This is millimeters squared. Divided, same thing, right? Pi 10 squared, and that's millimeters squared. Okay, so here we go. So I got my 647 in my calculator, divided by pi. I don't know if I have a pi button on my calculator. Is that a pi? Yep. Equals, divided by a 10 squared is 100, isn't it? 2.06. And what is that? That's newtons over millimeters squared, which is what? Remember, we just did this. The extra m, that's 2.06 megapascals, okay? And the other one, 479.6 divided by pi equals error. I put too much junk in my calculator. There we go. 152.66 and then divided by 100. 1.53. 1.53. And that's also newtons over millimeter squared, so that is megapascals. Okay? And there you go. Is there a secret to solids? The number one secret to solids. Okay, here you go. I mean, once I let this out, y'all are going to be like amazed. It's just units, man. In solids, you're gonna have more equations than we ever had. I always give my students an equation sheet because there's so many equations in solids. If you can make your units cancel out every time, you can almost always get the correct answer, okay? So this is normal stress. When we come back, we'll talk about shear stress, okay? Here we go.